Cool. Let's start. Hello, everyone. Thanks for joining. We're going to go through the feature that adds resource locks to Manila in the Bobcat release. And we can give you an overview of what this feature is for and what the code looks like through this collab review. And we're trying to resolve any contentious issues that are pretty big that we can go work on right now since we're at the feature proposal freeze. These have been ready for a little while. We've just been testing integration with Nova and trying to get feedback from the developers on the Nova side. So let me share my screen and let's start looking at this together. Right. So the links are on chat and they're also in the Etherpad that was shared on the meeting notes. So if are you able to see my screen? Is that working?
Yes.
Okay, cool. So you should be looking at the Etherpad. And so feel free to add notes to the Etherpad if you have questions and stuff that you want to hold off for. But let's go through the changes. So this change is actually split into multiple, and a lot of them are in Manila. And there's one change to OpenStack SDK to integrate this into OpenStack SDK so that it's easier to consume within Nova. So why does Nova need to consume this? Well, the whole thing started as the use case was driven by Nova. They wanted a way in Nova to be able to attach shares. And when you're attaching a share, they wanted a way to prevent that share from being deleted, from being, from the access rule for that particular share when it's getting attached to the Nova compute node. They wanted a way for the end users to not be able to discover the compute node through that access rule. So as you all know, when you allow access to a particular instance or anything like an IP address or a CEFX rule or a certificate or something like that, you're going to see as a member of a project, you can list the access rules, you can see details regarding the access rules, so you can see who's given access to the access to field. You can also, in case of CEFX, retrieve the access secret via the access list. Like all you have to do is just do a Manila access list on that share, and you will see these details presented to you because that's the security model that's there. So all members of a project are trusted enough that you can share these details out to the all the other users in your project. But if Nova is trying to mount this, Nova goes through the same exact interfaces as a normal user. It's its API is actually pretending to be the normal user when it's doing the attachment and stuff. So when the way it would expose a share would be to mount the share on a compute node and then plug it up to the virtual machine that's running on the compute node using VirtuoFS. So that's the part of the code that's there in Nova and stuff. And when they were doing this, they realized that they have to request the access to either the IP address of a compute node or to a Ceph user that they have created or to a certificate and so on. So when this access rule is available and visible and manipulatable by other users that are there in the same project, including the user that requested the mount. So they wanted to prevent a couple of things. One, by accident, somebody going and manipulating the access rule when the access rule was facilitating the Nova mount, and that the Nova was actually using that particular share and showing it up. And two, malicious access, right? So as an end user of a cloud, you don't really need to know anything about the compute node, and that would include its IP address if this was happening over NFS. So that's the intent of this. And so they wanted us to have a way in Manila to prevent that. And another thing was, in case Nova has mounted a share and you are trying to delete the share, you're always able to do that with Manila today. Even if there is a workload that's consuming a Manila share, you should be able to go to Manila and just say Manila delete. And the reason is that it does not know, Manila does not know anything about who's consuming the share, who has mounted the share, like whether there's some active read or write happening on a particular share and so on. So Manila will just let you delete a share that's in use. So with Nova, that can become very problematic because you might end up mounting the share on the compute node, and this could be a hard mount. And if the share disappears from underneath, the compute node's just going to wait until the share the server is responding, or it might just end up crashing, and you now have a denial of service. So the infrastructure has gone down, and because of some users' interaction with Manila. So they wanted a way to prevent this. So if at all, if when Nova is mounting a share, they want to be able to lock the share so it cannot be deleted by other users within the same project, or even by the user that has mounted the share until they go to Nova and unmount and free up the share. They shouldn't be able to delete that share. So that's the second interaction they were requesting from us. So that's what this feature is about. It spawns into these patches. So I can take you through the resource locks implementation, and then Carlos can step in and cover the access rules locks that are there. So the resource locks, and please tell me if this is, you know, uh, legible on your screens.
Yeah, it is.
Okay, perfect. All right, let's start right at the router. We are introducing a new resource lock endpoint, and it will allow you to do most actions that are this thing. So there are no special actions here. What that would mean is, let's go back to the API and you can see what those actions are. So you can list resource locks. You can show a particular resource lock. You can delete a resource lock. You can create a resource lock, and you can update a resource lock. So it looks very familiar if you're looking at it from an API perspective. All of the API behaviors, such as get, put, post, delete, are here. Um, yeah, so let's probably go through the creation workflow, right? So what we do in this layer, which is the basic validation that we're committing to over here, we go ahead and check the body, and if everything checks out, we go ahead and create the resource lock in the with the resource locks API. Uh, the reason this is split like this, you'll see in just a little bit. I'll show you what that resource lock API file looks like. Um, and we do some standard error handling, such as the resource that you're talking about, you're trying to lock a share and the share does not exist. So we're just handling those sort of errors and returning, if nothing happened, you're going to get details of a lock, pretty much like creating any other resource in Manila. And you can do the same thing for update, except for update, you can only update a couple of fields on the resource log. And you'll see that when we go to the check body, and then we just go back and return the detailed lock as it was updated. Same thing for delete. You can delete any lock at any time, and you can also retrieve details of the particular lock, and you can get all sorts of fancy filtering with a particular lock. I mean, with the locks. So you can list all the locks on your project. You can list all the locks for a particular share. You can list locks with any other filters that you're familiar with Manila, and you can also paginate these locks and so on. So that's the index method. Let's just look at the basic validation that's happening here. We are enforcing some things like you can't have a lock reason that's greater than 1023 characters. You can't update anything apart from the resource action and the lock reason. You cannot create a lock for something that is not really a resource. You need to have a resource that you're locking. And we are going to control the number of kinds of things that you're able to lock. And right now, with this patch, you can only lock a share for deletion. And in the future, we kept this stuff open for extension, where you can lock other things, like you don't want to allow a snapshot from getting deleted, or you don't want to allow a replica from getting deleted, or a share group from getting deleted, or so on. We can actually add different locks at different times, based on if this use case makes sense. So that's what the the use case here is, let's go back up and look at the resource locks API. So this is one level down into a little more detail, right? Let's start with the create and the update and the delete. So these would be the critical piece of code that actually do what you're expecting them to do. So first things first, we check for a policy whether you can create a resource lock on the resource that you're locking, that you're requesting. So we grab the resource. If it's a share, we grab the resource from the database, and we check whether you can actually create that lock. Are you a user that's authorized to create a lock on a share or on that particular share? Does the share belong to you, and so on? So that's a policy check. And then we look for what is your context? Who are you really? And that basically is these checks where we are asking, are you a service? So are you Nova? Really, that's what the thing is. So the idea that in OpenStack, when a service is interacting with another service, like Nova is making an API call to Manila, it will use a dedicated user that has a dedicated role called service. So if you have a service role, then you're a service, and so on. So that's the idea here. So if you're a service, the lock context is something that we'll record, and we'll say the lock is created for a service. If you're an admin user, the lock is created for an admin, right? And you can have n number of admins, and so any of those admin users creates a lock. That's an admin lock. And otherwise, you're anybody else, you're just a user that the lock is created for. And we'll just go through the policy file in just a second, and you'll see there's nothing different here with respect to that, based on, the policies are pretty standard compared to the other default policies that we ship. That is, as a reader, you can't create anything. You can only read locks. As a member, you should be able to create locks by default. And as an admin, you can do everything. So that's the idea. So we record this lock context. And why is this lock context useful? Let's go back to the create method. So we grab the lock context. I'll tell you why it's useful in just a second. We go ahead and create the lock in the database. And when it comes around to be able to update the lock or to delete the lock is when we go back and look at the lock context. So if somebody comes along and says, here's a lock ID, I need you to update this lock for me. And we first ask, do you have permission to update that particular resource lock? Is that lock belonging to you? If it does not, you're going to get a 403 or a 404, depending on how this is accessed. Do you, as a end user, have the permission to unlock something that somebody else has locked? Like, for example, like that's what this check allow lock manipulation does. It's looking for the resource lock was created by a service user, let's say, and an end user is trying to unlock it or update the lock or delete the lock or whatever, right? So an end user is trying to do this. That's not allowed. So if a service creates it, only a service can unlock it or a service can update the lock. If an admin creates it, only an admin can update or delete the lock. If a user creates it, a service can update the lock, a service can delete the lock, an admin can update the lock, and admin can delete the lock. But that's just the privilege levels of the locking that's happening here. So technically, if a service creates it, the lock is still owned by you as an end user because the lock was created on your behalf, but only a service can update or unlock that lock. So that's the idea. So that's what will happen when you're trying to update the lock or delete the lock. We're going to check for whether you're allowed to do that particular thing. And if you are, we go ahead and let you do that particular thing. That's what, so this file is mostly to handle that logic of lock manipulations as well as lock context. So I just wanted to keep that out of the basic API validation that's there. And you have the same get all filters happening here and so on. So if you're an administrator, you have the default policy that allows you to get all locks from across the projects and take a look at them or get them for a particular project ID and so on. All right. So that's what this the API looks like. And let's see anything else that's useful in the API layer, maybe the view builder, just to see how the lock looks. It looks like this, and maybe it's not too useful to look at this. Maybe it's useful to just look at the sample. So if you created a lock, that's the response you're getting. If you are oh, sorry, this is the response, not that. So it looks like this. So you're going to get the user ID and the project ID of the particular user that created the lock. You're going to get back the lock context, the resource that was locked, what was locked on the resource. In this case, it was a share, the share ID, and it was locked for deletion, which means that no other user, including this user, as long as the lock exists, they can't delete the share. That's what this means. And when the lock was created, updated, and the standard pagination responses. We still have the bug that Maurice raised, and we're gonna fix that bug across all of these resources. As you can see, the API is resource locks, and there's a resource underscore lock. So this link is not going to work when you try to resolve it. So we'll fix that across all of the resources. So a get all response looks like this, just a list of those locks, and a get response, a lock detail, a lot like the create, and an update response also looks a lot like that. And there is actually a doc on how do you use these resource locks, right? Because now we are parallelly adding support in the OpenStack client, in Python Manila client. So this is how you would do it. So you would do OpenStack share lock create and the name of the share or the ID of the share. And this is a resource type. So my share is a share. So I don't think we've defined a default, and that's because we have other resource types that are getting added. So you'd have to do it this particular way. And then you could get the locks for a given share. You could show locks, OpenStack share lock show, and then assume that you have locked a share. You can do a OpenStack share delete on on that share, and it will show you that it'll give you an error, and it says there are a bunch of resource locks. In this case, there's just one that's preventing it from being deleted. So if you delete the lock, and then you can go ahead and delete the share because there are no more locks. But you get the concept here that you can have any number of deletion locks. And that is to support a way that, let's say Nova is mounting the same share in 5, 10 different places. It would like to have these locks happen atomically. So as the mount happens, lock the share, lock the share, lock the share, and so on, so that it can remove the share lock that it took for that particular mount. And so eventually, when there are no more mounts, ANOVA will end up removing all of the locks. But it does lock removal per unmount operation. And that's how we would expect end users to use it as well. Maybe you don't need more than one lock at any given point of time, but assume there are two users that are simultaneously using the share and want to make sure that both of them don't get the share yanked from underneath them. They can both uh, set a lock on the share. And the only people that can unlock the share for them if they are not there, like for example, if a user exists in a project and then no longer works for the project, right, moves on, but they have a locked resource, is by default the only other user that can unlock a share is the administrator. They can list the lock, they can remove the lock, and and then you can free up the resource. That's the idea. Um, what else? I think the rest of it, I think one other interesting thing is for the first time, we're actually acknowledging a service user, and Keystone passes a parameter called service roles in the context object that we get that we create with the Keystone token. And so we're looking at that, and if there are any service roles, we claim that it's a service user, and that's been working so far. And there is a migration, a database migration that creates this table. There are no data migrations that are happening, just the aspect that we're creating a table that we need to store all the locks. That looks pretty standard. And there's a bunch of APIs, database APIs. The biggest method, of course, is the filtering logic, I guess. So you have a way to filter locks with a bunch of different things. And trust me, I mean, this code looks a lot familiar with other filtering things that have looked at the in the DB layer. There should be nothing unique about this, and that's I really like that because we've started pushing a lot of the pagination and the filtering directly into the database layer. So these are primitives that we're able to use across other things as well. And these are using the new way of doing session management in the database. And what else? I think now we've looked at most of the things. We should just look at probably what the um, deletion locks actually look like. So if you're trying to unmanage a share, we will first check whether there are any locks. If you're trying to soft delete a share, we'll first check if there are any locks. If you're trying to delete a share, we'll first check if there are any locks. So what is the checking for locks looking like? It's a decorator in this file. It is it's just looking up all the locks for that particular share across all of the projects using an elevated context. And if there are any locks at all, it's going to raise an exception saying you cannot delete this share because it has been locked. And that is it. I think bunch of unit tests and stuff. Uh, and I think one last thing we'll look at is probably the policies. Bunch of deprecated policies that we begin with. Unfortunately, we will try to clean that up in the C cycle. So who can get locks? An administrator or a service or a project reader can get a particular lock. Who can get all of the locks? An administrator, service, or project reader. Who can get locks from all projects? Only an admin or a service. Who can create a lock? Well, an administrator or a service or a project member. Who can update a lock? We now have a concept of an owner user. So only the user that created the lock can actually update the lock if you're a regular user or an administrator or a service. Who can delete the lock? Same thing. So we're using these policies quite a lot in those APIs. As you can tell, we pushed most of that logic to determine the locking aspect into the into the database, into the policy checks. That's it. Uh, so that's in short. I think I took like 20 minutes. Are there any questions? If there are none, there is a client patch as well. And this is only for OSC. There is no Manila shell implementation. So take a look at this. It's uh, pretty straightforward as far as client implementations goes, I think. So the client also implements the Manila SDK, Manila client SDK that we'll end up using. But we have no Manila shell implementation that's coming, and that's by design. We're actually ceasing work on the Manila shell. What else? And yeah, there is also already Tempest tests for this stuff, positive, negative test cases, and it does all the things that you'd expect, like, user A locks the share, user B wants to unlock the share and stuff. And I'd take a look at that and see if there are some gaps that you think that we can close. It even tests deleting of locked resources as are the locks working as expected, and bunch of API negative tests. What else? I think that's about it, and I think I should probably hand over to Carlos here. Any questions though before I do that? All right, looks like none. Carlos, all yours.
Sure. Okay. I think I'll do screen sharing.
Yeah.
All right. Can you see my screen?
Yep.
Yeah. Okay. So as Gautam said, we need two things for the virtual OFS work. One of them being the ability to lock the shares, and the other thing, the ability to redact some fields from the access rules, so we wouldn't leak like nov IPs and access keys from the access rules, but also we wouldn't have we wouldn't allow the deletion of an access rule that is currently active in a share that could be still in use by a Nova instance. So we needed some work in the access rules, and we are calling that restricting access rules. It's changing a bit now, but most of the work here relies on some API changes and a couple of things that I'm just showing. But in the beginning of the implementation, we were thinking about something like introducing new database changes for the access rules and so on. And we thought it could be like more painful to get that behavior when we already had the other structure, like the access rule locks or the share locks being implemented. So we thought about like taking advantage of that code already being implemented and make these access rules visibility restrictions and the deletion restrictions also using the resource locks. So and that's basically what we did here as well. So after some discussion, like most of the code relies on the API, as I said. So some of the things that we needed to allow are, when you are creating an access rule, you should be able to specify 3 new things now, which is lock deletion, because if you want that access rule to be locked and no one else to delete the access rule. Also lock visibility, if you don't want anyone to see like the fields of like the sensible fields of your access rules, like your IP or access key or something like that, and the lock reason as well. So so the allow access method, it's changing. So in case it realizes there is like a new lock visibility or lock deletion being passed, or the lock reason as well, then it will try to create some locks. The first thing it will do is if either a visibility lock or a lock deletion or none of those were provided, and there is a lock reason, we shouldn't allow that, because the lock reason should come alongside the lock deletion and lock visibility. So that's the first validation we do. And then if there is a deletion lock requested or a visibility lock requested, then we go to the next part, which is actually creating the access locks. So for creating the access locks, the access rules, the first thing when enforcing the policy, like we are enforcing the policy in an object. So we needed to ensure that the access rule had the project ID and the user ID in it, and we actually didn't have. Because that's not a part of the access rule in the database. It's not contained in the model, and it's not a part of the table. So we don't store those fields for the access rules. So we get that from the context, and we attempt to create 2 locks. So if a lock deletion was requested, then we create a new lock just using the code that Gautam was just showing. So I send a request to create a new lock for the deletion of the share, specifying all of those fields like the context, what's the resource, what's the reason for the lock. And then if there is need for a lock visibility as well, for locking the visibility as well, then we'll do the same. But in this case, the research section is going to be research section show. So it's basically reusing the same code Gotham was just presenting to us. And for this case, for example, if the creation of the lock fails, then we just like raise bad request because it failed with something during the creation of the lock. Could be anything. But if it fails during like the second lock and the first one was placed already, then we need to roll back the delete possibly. And this could be one of the discussion points. But that's one way that I was thinking about, like the rollbacks in case one of the deletion locks fails to be placed. So that's the two things we do in the creation. If there is the need for creating a deletion lock, then we do. And then if there is the need to create a visibility lock, then we do it as well. So that's basically the two things for the when you are creating the access rule. So now you'll be able to specify lock deletion or lock in the lock visibility fields, and in case you want those locks to be placed, and also the lock reason. For deleting the access rules, then it's kind of we need to ensure that the access rules don't have any deletion locks placed in it. So what we do in this case is before actually sending or doing anything with the request to delete the access rule or sending it to the share API, we basically call a function that will do some validation. So one other thing the API accepts now when you are unrestricting or deleting the an access rule is a field called unrestrict. Because if you know there is a lock placed in that resource and you want this to be deleted without any failure, so you need to send the unrestrict parameter. And we will do like a search in the database. So we will try to fetch the locks using the resource ID, which will be the access ID. So we will look for logs we use that were placed using that lock ID, access ID. And we also we also include in the search the delete. So we are looking for locks, for delete locks using this access ID. So we can ensure that we will retrieve only the locks placed for this access rule. And then we get the locks and the count of the locks. So if there aren't locks, then we don't need to worry about anything. So we already return. But if there are more locks, like if there is more than one deletion lock, it means that other user has placed the deletion lock on the access rule as well. So we just raise an exception like forbidden, and we ask the user to remove all the locks before actually deleting the access rules. So that's basically what we do. So in case there is only one deletion lock remaining, then we attempt to delete the locks. So that's basically like some logic. We'll try to ensure that the context will be able to delete the lock, and if it will do all of the policy checks Gautam was just showing us as well. It's reusing a lot of that locks code, but that's it. I mean, in summary, that's basically what we are doing here, ensuring that there are no locks placed when we are trying to delete. So that's basically what this is doing. So the changes rely mostly on the access deny and the access create. So whenever you are creating new access rules and you want locks to be placed, you can do that through the new parameters. But if you want to delete the access rule and it's locked, you must ensure that you also send the unrestrict parameter in the request body, so it will attempt to remove the restrictions of the access rule. And this is the part for the access allow and access deny. But also there is the part for listing the access rules and showing the access rules, because if a visibility lock is placed, then only the user that placed that lock should be able to see the sensible fields that we called like the access to and access key. So here in the access, I think Zoom, I just got a message from Zoom, but yeah. It's basically in the share accesses API. What we'll do is when we are trying to show an access rule, we'll look for locks. So it will call the is rule restricted method now, and it will look for locks in this specific access rule. And then the action we are looking for is show, because we want to look for locks that are restricting the visibility of this access rule, and the resource type is going to be access rule. So this will retrieve us a couple of locks, and then we'll send a request or a call to the resource locks API. There's a new method there. I'll just go show that to you. But the resource locks API will do a validation and check if the access is restricted for this request with this user. And if it is, the views will redact those fields. So it will append like the visibility stuff. Like it will basically, this method will return if the visibility is restricted or not. And if it is, we'll turn the share access that was provided to us by the database, and we'll turn this into a dictionary and assigned like the restricted to true, and then the view will take care of redacting this when there's restricted set to true. So this is for show. When you show an access rule, it's going to be redacted with this code. And also, when you are listing access rules, we do the same thing. So we do the same process. So we get a list of access rules and everything. But what we do here, we get the list of access rules, go over every single item, and then we check if they are restricted or not. So then the index, when you are listing access rules for a share, if one of the rules is restricted, you shouldn't be able to see any of the like access key and access to fields. So that's the two parts, like with restricting the deletion and removing the restriction, and also listing and showing. But there is also one important part here in the resource in the lock API. So lock API, yeah. So introducing a new resource, as Gato mentioned, like this is flexible. If you want to add more resources in the future, it's going to be easy, just like this. So we do access is restricted. It means that what it will do is it will get the resource lock that you are sending, and it will get the lock context of it. So lock context means if it's an admin that plays the lock, if it's a service, or if it's a user. So if it was locked by an admin and the context that is asking for that resource is an admin, then no, it's not an admin, then yes, the access is restricted. Or if the access rule was locked by a service and the context is not an admin or a service, then yes, it is restricted. You cannot see what's in that access rule. And if the access lock was placed by a user and the user ID in the context, in the request that you're sending, is not the same that placed the lock in the access rule, then yes, it is restricted as well. You shouldn't see any of the sensible fields there. Otherwise, the rule is not restricted. You can just we just return there. And a couple of other changes as well, just to ensure that we can integrate the access rules locks there too. But yeah, that's pretty much it, I would say, for this locks API. And also there's some important piece. There's one important piece at the views, I think. So let's see. Yeah, views. Yeah.
May
so
I interrupt?
Yeah, sorry. Go ahead.
Can you go back to the access is restricted? So that means an admin cannot view if a user has restricted.
If a user has restricted that, the admin would be able to. At least it should. I might have done something wrong. So lock API. Yeah, if it was locked by an admin and
or if it was locked by a user and I am an admin,
then it should be okay.
Carlos, just one point. I think this function, it's a core function. Its logic here is very important. I think we could add like a doc string and document the function saying, okay, those scenarios restricted. So changing those code to a documentation in the function itself. Okay, so I think it's easier when reading. I know what kind of scenario is covered, so then I can map to the code, because I think this function doesn't have any documentation, and this is a business logic, and it's nice if you have like very clear the logic that access is restricted is this one. Admin can user admin can remove, and placing the scenarios as a doc string so we can read and make sure that the code reflects what the business is. Okay.
Yeah.
So just summarize what you said, but in a more documented way. Like doc string explaining those scenarios because they are very important. And I, since you're speaking very fast, I know we are running out of time. But yeah, if you like place the business case that you should support, then I can map to see if this code is right, and we can keep track about the scenarios that we cover.
Sure.
But
Yeah,
I think
thanks
you're
for the
right.
feedback.
Carlos,
No,
one question. This is Janan.
Yeah.
So if resource is locked by user, can admin remove that lock? That condition I am not seeing here in line number 63.
Yeah, it should be able to. The admin should be able to remove the restriction of the lock. I think this access is restricted is mostly being used by the show and list methods. So this wouldn't be called, if I recall correctly, by the delete. But yeah, the idea is that we will not allow we will allow the administrators to delete a lock that a user placed. Administrators and service, they can like manipulate all locks. Users can only manipulate the locks that pertain to them. So yeah.
I think I have the same question with as Maurice did. I think what you need on line 63 is that not just the user check, you should also check if it's not an admin.
Yeah.
So that you're not restricting admins from seeing the stuff.
No, it makes sense. Yeah, I was reading like this again, and it makes total sense. In this scenario, it will only allow the same user to see. If you're an admin or if you're a service, you couldn't see this. So we should add the same like in a new condition, like, and not context is admin or context is service. So
it's another thing I think is this is the same exact logic as the lines above, check lock manipulation.
Yeah.
So if you really want to, we could just combine those and call it something else.
Yeah, it was a bit different between the patch set compared to the patch set I submitted today. So I think yes, it makes sense. So we can reuse some stuff, but it used to look like this. So if a different use before, like the logic was, if a different user on the lock and the context, the request context was an admin, or sorry, the request context in this case is we trying to get the context. So in this case, if you're an admin or if you're a service, you would be able to see like every field, and even if a user placed the lock, you should be able to. But yes, I agree, we can reuse some of the logic there.
Yeah, and we could probably call it something that's not check allow lock manipulation or something. We can just enforce lock logic or something, some such stuff, and write a doc string like what Felipe was suggesting.
Yeah, it makes sense. Thanks. Right, so yes, I think that's pretty much it on the logs API too, and I think the views as well. The views, they are what I mentioned, like when we tagged an access rule as restricted, then we'll just redact the fields. And this is not something I was really sure about, like only adding this hard coded. And like in the previous patch sets, I had like a to-do to ask for feedback here. I don't think it's like ideal, but I don't know how deep we want to go, like actually trying to encode something and providing it to giving it back to the API or giving it as an answer to this API. But yeah, initially put only like some asterisk there and returned. But we can discuss this. I don't have a problem of changing it. I think it's kind of fragile. I don't know. But yeah, that's it. I think mostly for the core change, and there's also like a client change for this. Only in the only change we have on the client is for OSC as well. So the new parameters, as I mentioned, like you can now specify lock visibility, lock deletion, and lock reason. And yeah, it will just send those. There are Tempest tests as well, but Tempest tests became like outdated with the changes I proposed this morning, so I'll be updating those. But they were passing, and I was doing a lot of tests with these scenarios we were just presenting. So yeah, any other questions?
No. Just that secret that you show is the way that the API returns to the color. Is the star like have like several stars? The views, yeah. This is like the line in 41.
Yes, that's exactly it. That will be
Okay.
returned for both
Just
access
to
key and access to.
just to hide the information. That's the goal. Okay. Yeah, I don't know from the color perspective, what is the impact of having like stars or having no information? I don't know.
Yeah, I
what
kind
is
of agree with you. I didn't like that in the spec itself. It was suggested by somebody in Nova that they wanted to see those redacted stuff to I think differentiate between has that field been populated yet or not, or some such thing. So that's why, I mean, but we didn't really argue too much on the spec. We just went ahead and made the change saying it'll be like this. But if, let's say, a client is looking at a host field for the access to, or doing some sort of a validation, that's going to fail.
Yeah. And another thing that I'm a bit afraid is that you should like take care the number of stars if you want to match with this guy for some script logic. And like there's 1, 2, 3, 6 stars. So if for some miscoding you type like 5 stars, it won't match. Okay, so that's the problem of adding. It's I think that I got the idea of having just having the way that the user will see in the server, but I think the client layer, the client side can transform this in a more user friendly way.
Okay.
From the server side, I think that what we should think is what is the impact for a coder that will parse this, okay, will get this and present this to the user, because that's the goal. Okay, no one is gonna call the REST API directly. It's gonna take this and do some kind of transformation to the end user. I don't have problem keep with this. I just want to understand what is the advantages of having several stars instead of having like a message or a more server way, because I haven't seen this kind of return on the server side.
Obfuscation.
Normally it's more like a message or something that you can document, like this when this field has this fail, this like message or this status, it means that, other than having like some weird characters that mean something. So it's not common server way of returning things. So I haven't seen this, but yeah, no problem. If I think Nova team like this approach, we can keep with that. I just want to understand the advantages.
I agree. And we can think about this, and I'll see if there's some standard around this for REST APIs. I understand what you mean by let's implement the client to be a little more user friendly. We certainly can do that with the SDK as well as the client, the shell client.
But yeah, overall it looks good. Nice work, Carlos and Gotham. And from my first view, it seems that everything is as expected. I think probably we need some offline review for more details. I just have one question. Does it work in a active API environment? Have you tried this kind of thing? Because I know you're like creating lock. I saw like some counters. You're relying on like if you have one, it does something. If you have two, it goes to another flow. So when you have like think that this kind of thing that you read from the database, then you starting rely on that information that in the counter. And if you're running within a active API, you can like starting when you read from the database, another guy go there and creates a new
lock, like you
new
like a
lock.
race condition.
Yeah, have you
Basically,
tested this kind of things or have you?
we
I'm
could.
not really.
Mhm. Go ahead.
No, I just want to ask you if you test this kind of tests and if you took that in account.
So it's got to be a narrow gap, for sure. But if I mean, I don't think we have tested it like that. I mean, and when you say active API, that's how most people are using it, right? The API always
Yeah.
has multiple workers. So even if it is running single service exposing, it'll be on a multi-threaded process by default. So even if you're running it on the same host. So I think what you're asking for is, let's say somebody is trying to create a lock, and then you're suddenly trying to delete that resource as well. Do we check for that? And we don't at the moment. Like if both those requests come in, and if the lock gets created, it might just error out, and the resource deletion might just go through, depending on what wins the API race at that point. And while creating the lock, I don't think we even check for the state of the object. For all you know, it could be deleting, and so this might actually be doing the wrong thing.
Okay.
So that's a fair question, and we should probably look for the state aspect of this, because if something, let's say the access rule is queued to deny or denying, then it makes no sense for us to allow creating a lock on it. Same thing as deletion of a share. If it's deleting, there's no reason to allow a lock on it. And if the lock wins, then I mean, of course, the deletion is just prevented from the top. But on the other way around, that is that's a fair question. We should probably look for that logic.
And also, I had another question. What is the plan? The plan is having those patches merged during the Bobcat, right? During this month.
So the this thing of this is these two patches merged in Manila, the OpenStack SDK patch merges, etc. That we allow Nova to have all the pieces to go ahead and finish their VertiOFS work in this cycle. And in this cycle, what they're aiming for is for cold attach and detaches. So it is sort of like a soft launch of the VertiOFS feature, if you ask me. They're planning to add more functionality to this in the C Caracal cycle and D cycle kind of a thing. But for cold attach detach, just having this is what was mandatory. So I think that's the goal, to try to get these merged and landed to, so a bunch of patches can merge in Nova as well.
Okay. And I think my last question, Rams, from this presentation, it seems that all Locker logic is on the API layer, right? So there is no impact for driver maintainers, right?
Yep.
In a way, or I'm wrong. I'm not totally sure, but it seems that's totally on the drive layer, on the API layer, right?
Yeah, there is nothing that's going across the RPC wire for anything.
Don't need to worry on the OCIs or something like that, right?
These tests should be running against all the drivers, and they should just pass. There should be no driver dependent stuff.
The Tempest test, they are just like creating share and locking a share and then unlocking share, and so the lock phase, all operations doesn't they don't reach the driver, right?
Yep.
Yeah.
Okay, that's nice. Okay, thank you for the presentation.
Awesome.
I will
Thanks
do
for the
some
questions.
reviews.
Yeah, no problem. Thank you, and feel free to take the feedback back to Gerrit as well when you're looking at this patch. Any other questions?
I'm thinking of edge cases. Can we have multiple access rules with the same content? I mean, what happens if user A creates an access rule that is locked and not visible, and user B comes and creates the same one?
Oh, the API prevents you from having duplicate access rules. And by duplicate, I think it looks for a combination of the access type and the access to fields. So if you
Would
could
we
have
leak information?
do we leak information that there is an access that exists?
Yeah, I think so.
Yeah, we do. So that will be like but that's a fair question. So it's a protracted attack per se. So would we rather? What would we do?
I don't know.
So that's typically the case only for NFS.
Allow duplicates. Yeah.
Allow duplicates. Yeah, I'm not sure how drivers will behave when you have duplicates. Unless, there's some way of mapping the access to and access type separately for ourselves and presenting it to the driver as one list.
Yeah.
Yeah, it's a fair question.
Maybe I don't know if we could look for locks. I mean, if an exception like raises for something that was found already in the database, maybe we could look if there are locks, and then if there are, then we kind of try to redact the access rules from the message as well. But I don't know if we
No, the message clearly says there is a duplicate rule, right?
Yeah.
Access already exists is the error. So
Yes.
I mean, unless you change that to HTTP 400 forbidden and then HTTP 400 pad request, no message whatsoever, because the rule is locked. But then it's so easy to figure out that the API is only giving you this error because there's a rule there.
Yeah.
Yeah. I think it's a caveat we can note and see if we can if there's a way to prevent this. I do think the duplicate stuff will help us with other things as well. Like for instance, Nova will have a more atomic action. Like even if you have multiple shares, you want to mount on the same. Sorry, if a share is getting mounted on the same host multiple times. I hope not, but if you do, and you might want to request multiple access rules because you don't want to look and see whether the access already exists for that particular compute host and so on. That might be a thing worth thinking about. Thanks for the question. I think that's or I mean, at least if we're not going to do anything about it, we'll definitely have a a big caveat saying this is not protecting you against disclosing that a rule exists if somebody tries a brute force attack and lists an IP address or something. It should definitely only impact NFS that way, IP based access.
Yes.
Yeah. Awesome. Anything else? All right. Thanks, everyone. I hope you can, take a look at the patches and provide any more feedback that you might have. But it was great walking you through these changes.
Thanks for the session.
Yeah.
Thank you, everyone.
Thank you.
Thank you.
Take
Thank
care.
you all.
Thank you. Goodbye.
Bye bye.